Hi, Dave McDonnell from the IBM team here, and I'm here to explain cloud-native applications and data services. The world is changing the way that it writes software. It's now building applications to be what we call cloud-native. This means you can develop them in the cloud, run them in the cloud, or you can also run them in your data center. Or you may even choose to run both at the same time in different parts of the world. So that's a cloud-native application. That's simple. But the architecture of these applications is quite different than traditional applications. Traditional applications are written as long pieces of monolithic code. These applications can have 1 million lines of code, and people brag about how many lines of code they have in their application. And they should brag about those applications because they're very difficult to write, they're very hard to get working, and they're very hard to maintain. Modern applications are written in smaller chunks of code, and those chunks of code are called microservices. Now, I write smaller pieces of applications, and those together constitute my overall application. Let's pick an example of building a cloud-native application and pretend that we're going to build a cloud-native application that's a calculator. So it's a calculator with 4 basic functions of addition, subtraction, multiplication, and division. So there we have 4 microservices that together constitute and build me an application. Now, when it comes time to execute that application, I'll have a user launch a job, and it could be from a phone, a tablet, a computer, doesn't matter. And those will get executed in what we call containers. Each container will contain an individual job. We'll have addition, subtraction, division, and multiplication, and those get taken to the computer to get executed. Now, that could be a server or a computer that you have in your data center, or it could be to a cloud provider. You have granularity, so you can even choose that some microservices go to one computer, some go to another, and some go to your favorite cloud provider. Wow, that's a lot of flexibility in a cloud-native application. There's another term that's important, and it's called the orchestration mechanism. How do those containers get carried to the right place? Well, the de facto standard in the industry is Kubernetes, or it's abbreviated as K8s. That's what takes these containers and gets them executed. There's a commercial version that we're investing heavily in. It's from Red Hat, and it's called OpenShift. So Red Hat OpenShift is a commercial-grade version of Kubernetes with a whole host of other services around it that help these modern applications get executed properly. So now, if we build an application and we write it on top of OpenShift, we can have it executed in AWS, Microsoft Azure, IBM Cloud, or you can take it and run it on premises. So you get all kinds of application portability. This gives you agility. This is very, very popular with customers writing their own applications because it gives them flexibility and saves them time. It's also very popular with software companies. As a software company ourselves, this allows IBM to devote about 30% of resources that used to do heterogeneous platform support. We can now repurpose them and focus more on innovation and give customers the features that they want at the speed that they want it. If you're going to deploy a cloud-native application, you need to have a conversation about data services. A lot of the data services that you use today were built for traditional applications. They don't work as well for these modern applications. So the first thing is just data persistence. In a cloud-native application, it's not a given that you'll even keep the data. But most enterprise applications, they want to keep the data. Now, if they're going to keep the data, it's going to be quite important to them, so they're probably going to want to back it up. There might be regulations that force them to do this. There might be a need to do analytics on this data or AI on this data. But the point of this story is backup is pretty much every person's largest application, because most applications running in a data center are all backed up. And another important consideration is keeping the lights on, or what we call in the industry is disaster recovery. So in context, let's go back to our example with the calculator. Maybe my moneymakers are multiplication and division, and I've got a revenue stream coming in from those applications, from my users. Maybe it's ad-based revenue. Well, I don't ever want to turn that revenue stream off, so I can invest and afford to invest in disaster recovery to make sure those components of my application never fail. So, data services for modern applications are different than these data services for traditional applications. So we say that modern applications need modern data services. So that's cloud native applications and the concept of data services that are needed to go with them in a nutshell.